Okay, so split this lesson up into two. This next part is the part that causes students a little bit more consternation. So you got to be careful with the adding and subtracting, because you got to be thinking, get a common denominator, and you do have to remember that you've got to add or subtract those numerators. That will get students in trouble. But then these are a whole different kind of type of problem. Right, the concept is this. You got to recognize where the main fraction is, and it should be obvious if the thing's written correctly. You can see that this is the main fraction bar. Therefore, this is the numerator, and that's the denominator. Okay, so if you keep that straight, the process is to get a single quantity in the numerator and a single quantity in the denominator. You don't want a fraction in the numerator, you don't want a fraction in the denominator. So that's what you're after. So right now, if you look at this, on the bottom, that's the issue that's giving you a fraction on the bottom. So we need to get rid of that. So what I'm going to do is, I'm going to multiply that. What would you think I would multiply that by to get rid of that x? An x. So just to be clear, I'm going to do an x. You know what? I'm going to do it in the front because you guys do better with it in the front. I'm going to multiply by an x over 1. And notice I had to do it to the whole denominator. I just can't do it to that little fraction part, because that wouldn't be proper math. I've got to do the whole denominator. Not only that, right now if I just do this, I've changed the value, so what else do I have to do? I got to do it to the top. So I have to also multiply the top by an x over 1. Okay, the top is no sweat. That's a 2x. But you got to be careful on the bottom because you have to distribute. All right, the first should be easy. And x times a 4 is indeed a 4x. But then you also have to distribute the x times the 1 over x. And this is the whole reason we did this. X times 1 over x is a 1. Come on, screen. So this thing ends up as plus 1. All right, notice we no longer have a fraction in the denominator, and that's fine now. The only thing else we'd look to do is reduce if possible. So you're looking at this thing. Does it reduce? Don't make the mistake of crossing out the x's, because that 4x is tied to the 1. Don't make a mistake of crossing out the 2 and the 4, because again, that 4 is tied to the x, which is tied to the plus 1. So this thing does not reduce. That's the final answer. I mean, that's it. We simply got rid of the fractions. Again, please ask questions as we go. Not only will it help you, it will help somebody else at times. So as we look at this second one here, I went one too far. As we look at this second one, same scenario. So you're looking at the fraction part of the numerator, the fraction part of the denominator, and you're looking at the bottoms of those fraction parts. So I'm looking at an n in the numerator, and I'm looking at an n squared in the denominator. And I really want to multiply it by one thing. So I got to multiply the bottom by something, and I have to multiply the top by the same thing. But again, it's the denominators that drive what I'm going to choose here. And it's not just the bottom denominator. So because there are denominators in the top and a denominator in the bottom, it's whatever the LCD is of those denominators, that's what I'm going to multiply everything by. So I'm going to multiply everything by n squared. The n squared will take care of the n squared on the bottom. The n squared will also take care of the n on the top. It's going to take care of both. Okay, be careful on the top. I see students do this all the time. This is what they do. So on the first one, they usually get it correct. It's an n, right? But then they usually want to say on the next one, plus 2n. They think like their n was gone from the n squared. But do you see how that's a mistake? It's an n squared that gets distributed to both. So the back here is a plus 2n squared. Just be careful there. Students, again, think like because the n's divided out in the first distribution, I only have an n left for that 2, and you don't. It's an n squared times the front, n squared times the back. All right, and the bottom is going to be a 3n squared plus 1. So I would look at this and, all right, I understand I can factor an n out of the top, but that's not going to give me anything. Because I'm just going to have an n times an n plus 1, and there's no way I can get the bottom to have an n plus 1. So, no value. The only thing I do on this one, Connor, technically is what? So do what? No, it would be the top. Technically, I should put the squared term first. And that's just a slight technicality. Good morning, Adam. Once you get settled, I'll take your homework. Okay, does that make sense? So we're getting rid of the denominators. It's all about getting rid of the denominators. Okay, so on this next one, same scenario. You're looking at the problem. B there, A there. Those are our issues. So again, we got to multiply the top by something, or bottom by something, and top by the same thing. You guys want to try this one? Why don't you try this one? See what you can do. Will you staple that for me, Adam? Will you staple that for me? Thank you, sir. Yeah, thanks. All right, so AB over 1, AB over 1. Distribute AB plus A squared over A squared minus B squared. All right, so on this one, you could factor an A out of the top, right? But you'd get an A times an A plus B. Right? If I put the A squared first and the AB second, I can factor out a common A. I get A times quantity A plus B. And of course, you see the bottom is a difference two squares. And you can see this one reduces. This thing ends up being A over A minus B. Again, you can't cross off those last A's because the bottom A is tied into the negative B. They're one thing. Two have become one. Anybody get it? Did I not give you enough time? Nobody got it? Where did you go wrong? Questions? Raquel? Did I get it wrong? Okay, all right. Just checking. Ileana's not here, so we got to check. All right. Raquel? So again, I'm looking at the bottoms, and that's why I circled the B, and the A. So there's only one A, so I need an A, and there's only one B in each case, so I need a B. And you can see when right here, that's AB, no problem. But when I multiply here, the B's divide out, and it's A times A squared. When I multiply here, the B's divide out, it's A times A squared. When I multiply here, the A's divide out, and it's B times negative B for negative B squared. So again, I need an A to get rid of that A. I need a B to get rid of the B. Any other questions, anybody else? All right, let's look at the number 10 here. This one a little bit more involved. So now I got all kinds of issues. I have an x plus 1 issue. I have an x issue. Thankfully, the same x plus 1 and an x plus 2. Ay, ay, ay. That's a lot of stuff. So for the top, I need an x for the x. I need an x plus 1 for the x plus 1. And I need an x plus 2, and I'm out of room for the x plus 2. And same thing on the top. Kaylin. Right here, this x is just all by itself. And unless I do an x, there'll be nothing to divide that x into. Like, I can't, just like if I had, Kaylin, if I had x plus 1 over x, I can't cross those out. So unless I had an x all by itself to be able to cross out with that x, so here's where I end up. Let me just show you the step. When I distribute this times the 4 over x, when I take this and do it to the back, now because I had that x, I get to cross those x's out to get rid of that denominator. So again, I got to get rid of all the denominators. The x plus 1, the x, the other x plus 1, the other x plus 2. Okay, let me do this one step by step because I think I'm losing you guys in the distributing. Okay, so first one. If I were to write this out, it would be x times x plus 1 times x plus 2 all over 1. Probably should have done that in green. Times the x over the x plus 1. And the x plus 1's divide out. Again, we got rid of our denominator. That's what we were after. We've got that negative sign. And again, I'm going to use the green this time. The x times the x plus 1 times the x plus 2 over 1 times the 4 over x. And here our x's divide out. Another denominator gone. We only have a numerator left in the numerator. So the bottom, the first distribution, again, x times x plus 1 times x plus 2. And it's that times the 4 over x plus 1. And hopefully you see the x plus 1's go away. Again, got rid of another denominator. And then we've got that minus sign, and again our x times x plus 1 times x plus 2 over 1 times the 2 over x plus 2. And lastly, we needed the x plus 2 to make that x plus 2 go away. And we've gotten rid of all of our fractions. We got a lot of stuff left, though. We got a lot of stuff. Okay, I'm going to do this top in black. I would, in my mind, multiply the x times the 8 so that I can distribute it. 8x times x is 8x squared, and 8x times 2 is a positive 16x. That's that top now on the left. Do I hear some mumbling? Question? What happened? Okay. Let me pause a second. I had an x. I had an 8. I had an 8x. And it was times an x plus 2. So I distributed the 8x to the x and got 8x squared. And I distributed the 8x to the plus 2 and got 16x. Okay? So again, see, there's a lot of rewrites here. If you want it easier, it just it requires a lot more rewrites. Here in this second one, I've got the negative sign, I've got the 4. So I have a negative 4, but I also have these two binomials. And again, it would help if you're able to multiply two binomials in your head. And you should be able to at this point. It's Algebra 2. X times x is x squared. Okay, that's easy. The outers is a positive 2x, and the inners is a positive x for a grand total of positive 3x. And then the back is a 2. But I'm not done yet, right? Because now I got to distribute the negative 4. So negative 4 times x squared is a negative 4x squared. Negative 4 times a 3x is a negative 12x. And negative 4 times a positive 2 is a negative 8. I just distributed all that. That's just the top. Yeah, you won't get many of these, thankfully. All right. Now I got to play with the bottom. Look, so here's the bottom. X times 4 is 4x. And I'm going to distribute the 4x to the x plus 2. So, oops, get rid of that. So 4x times x is 4x squared, and 4x times 2 is an 8x. That's that. On the right-hand side, got a negative. I don't know why you guys are freaking out. This is Algebra 1 at this point. We got a negative times 2 is a negative 2. Times an x is a negative 2x. Now distribute it. Negative 2x times x is a negative 2x squared. Negative 2x times 1 is a negative 2x. You're just distributing. You can't do that in your head, then rewrite it. Pamela. We're not ready to reduce anything yet. We have one big numerator that's all tied together by addition, and we got one big denominator that's all tied together by addition. So we can't reduce anything yet. Nothing. Now we got to add up all the tops. So look at the top. 8x squared minus 4x squared is a 4x squared. A positive 16x and a negative 12x is a positive 4x. And we just have negative 8. That's the numerator. Denominator. Positive 4x squared and a negative 2x squared is a 2x squared. And 8x minus 2x is a positive 6x. Now on this one, I'd have to check to see if this thing factors and reduces. And I already see that there's going to be a common 2, definitely. So this thing even reduces. What a great example. So I take a 4 out, I get x squared plus x minus 2. That will factor, but I'm not even going to factor it yet. The bottom, I can get a 2 out, 2 times x squared plus 3x. Even though this factors, is it going to have an x squared plus a 3x in it? And I can even get an x out. But is it going to have an x plus 3? No. So I'm not going to bother to factor it, even though it does. And even though I can get an x out of this, I'm not going to get it out because it won't do me any good. But the 2 and the 4 do reduce. So technically the final answer is 2x squared plus 2x minus 4 over x squared plus 3x. What fun. That was awesome. That was a great problem. Kirsten. You only had to go like 50 for 50 to get it right. So, Kirsten.
In the denominator, before you did like the bottom part, when you were doing the 2, and you had to distribute the x to the negative to everything.
Yeah.
When you do, so you have a negative x times the quantity negative x minus 1, and then you multiply the 2 by that. So.
Okay. Well, look. Here's what I did because it's easier. Negative times x is negative x. Negative x times 2 is a negative 2x. Now that's what I'm distributing to these two, because now I have just a negative 2x times this quantity. And it's easy to do in your head. Negative 2x times x, negative 2x squared, negative 2x times 1, negative 2x. So just take care of all the easy numbered ones first, and then dealt with it from there. Awesome. We have another page. We didn't even do, look, there's some like this, like 1 over 1 plus 1 over x. Let's see, how does this go? Like minus 1 over x, like that. Awesome. Like they just keep trailing down. They're so much fun. They're great. Okay, number 11. All right, the average is also called the arithmetic mean. Sometimes they just say mean for short. All right, these are weird. Find the average speed if Tim traveled 79 miles per hour for 1 hour and 74 miles per hour for 1 hour. Okay. We understand that if you do the mean, what do you end up with? You end up with, what, you're 5 apart. So half of 5 is 2.5. So you should end up at 76.5, right? Okay. But what I want to do is I need to do something with the units. Do you agree the average of a 79 and a 74 is a 76.5? Right? Add them and divide by 2. But these things are different if the units aren't 1. So I just want to show you this is the same thing as doing this. So to do the mean, I can do the 79 miles plus the 74 miles over, I know this is going to mess with your mind, 1 hour plus 1 hour. And we still end up at 76.5 miles per hour, right? True? Okay. You say, okay, so why did you even need to show us that? We just would have gotten 76.5 anyhow. All right, well, what would you get on B? Would you do 70 plus 70 divided by 2 is 70, and the answer to the mean is 70? Well, that's not going to work, because he went 70 miles in 2 hours. So if you're going to do the mean, you got to go 70 miles plus 70 miles, but you got to go over 2 hours plus 1 hour. I'm trying to show you the more complex ones because the bottom units aren't 1. Kirsten. Yeah, because he went 70 miles in 2 hours the first time, which really he was going how fast? 35 miles an hour. Right? And again, I'm using a simplistic example. So this thing ends up being 140 miles in every 3 hours, which when you divide that out is 46.6 miles per hour. Which makes sense, right? 35 miles an hour and 70 miles an hour, which is really what he was going. Now again, you could play with that and figure that out in your head, but what if we had like something with 7 hours and something with 11 hours? Well, now we know we can just add the hours in the bottom. Do you follow? And it all comes out the same. This can be done with feet per second. This could be done with meters per minute. Again, you got to make sure your bottom units match, though, and your top units have to match. You got to be miles, miles, hours, hours. You can't have hours and minutes, right? That obviously would not work. But it's just another way to come up with the mean. And that's not too tricky. That's not too hard. All right, let me get to the, for you musical people, what do you think that H is going to be? The harmonic mean. Let's get to the harmonic mean. Oh, yeah. Kirsten.
Sorry, do you want us to round to 1 decimal point?
It just depends. That's generality. All right, what's the formula? N over 1 over x sub 1 plus 1 over x sub 2 plus 1 over x sub 3, if there is one, dot, dot, dot. And if there's a fourth piece of data, 1 over x plus 4. And if there's a fifth, 1 over x plus 5. And you say, what is n? This is the number of values, the number of pieces of data. The x sub 1 is the data, the x sub 2 is the data, the x sub 3 is the data. Okay, simplistic example first off. Find the harmonic mean of 1 plus 2 plus 3. Okay, so h, harmonic mean. So what's n going to be? 3. 1 over x sub 1, make that the 1. Plus 1 over x sub 2, make that the 2. And this one does have 3, so 1 over 1/3. All right, we do have to be careful here, and this is why the tie-in to this lesson. Hi.
I'm sorry, can I have Antonio Chica?
Yes. Antonio. All right, the easiest way to deal with this. Now, you could get all common denominators, add up all the fractions, you're still going to have a number over a fraction. The best way to deal with this, let's get rid of the fractions, right? Isn't that what we were doing? We have a fraction, so we need to worry about the 2 and we need to worry about the 3. So we're going to multiply the bottom by what? 6, right? And whatever you do to the bottom, do the same thing to the top. All right, I'm going to come over here to the left. So the top is 18, no doubt about it. The bottom, the first distribution, you get 6. Talk to me, what do you get on the second distribution? 3. And what do you get on the last? 2. All right, good. So the harmonic mean is going to be 18 divided by 11, 18 11ths. That wasn't terrible. Something that comes to play with harmonic mean is the resistance in electricity. And there are parallel circuits and series circuits. So series circuits, parallel circuits, and the resistance of parallel circuits is 1 over R. Harmonic mean. All right. Sure you're aware of that, all you electrical people. Right over your heads. Science. Did you guys should have done parallel circuits and series circuits by now somewhere in science? Yeah. Yes? Okay. Good. All right. Find the harmonic mean of the Tomikins who traveled an average of 60 miles per hour the first day, 40 miles per hour the second day, and 30 miles per hour the third day. Tomikins? I could have used Kevin and made Kevin, but it would come out Cormican again, right?
Oh, yeah, that's true.
I should have used Melissa, the McCormick. No, that wouldn't work. All right, anyhow, who cares? All right, so finish that one out. Find the harmonic mean. Find the harmonic mean. Again, I did 3, so no big deal. If you can do without looking up, so much the more. Again, you're worried about an LCD, right, is what you're dealing with? I ended up with 40 miles per hour. Raquel. Which one you worried about? 120. So I was looking at 60, 40, and 30 and thinking about the common denominator. So 40 doesn't go into 60, even though 30 does. The next number for 60 is 120. And a 40 does divide into a 120, and a 30 divides into 120. Yeah, I mean, those are big numbers, so if I try to do the LCD chart, I mean, it would get long. So that one, I tried to pick numbers that maybe you could think about and come up with it. Come up with the LCD. All right, I got to change the numbers on your homework, right, because that was the original. So here's the new second day. So this is page 396. Do 33, 34, 37, 38. I should have said 37 through 40. 39 and 40. And I can't forget the green people. Greater than or equal to a B minus. Greater than a B minus. Do. What a mess. Greater than B minus. Do 50. 50. 50. Do 50.